Good evening, ma'am.
Good evening, all of you.
Good evening, sir.
Very good evening. So this is our chemistry class. So welcome to Sankalp learning session. We are going to start chemistry in this session. So I'm going to teach you chemistry in the for this CET course, and I wish you all the best for your exam. So do all the hard work, then definitely you'll get success in CET or NEET, whatever it may be. But it's all depending on your hard work. Okay. So let us start chemistry then. So all of you, please keep your audio in mute and don't write anything on the screen. So please make everything, whatever we are discussing, you make sure that you are noting all those important points. Right. So in this session, I'm going to discuss atomic structure. Atomic structure. Okay, so I'm starting with first PU syllabus. Then we'll finish off first PU syllabus as early as possible because more weightage is there for second PU syllabus, right? So I wanted to finish this first PU syllabus as early as possible. Then we can spend more time on second PU syllabus. So almost like every day we have to complete one chapter, right? So be regular to the class and please make sure that you are making note of all those important points. Okay, let us start then. Atomic structure. So this chapter will start with the word atom. So atom is taken from a Greek word, that is what we call atomio. What does that mean, sir? Atomio. So atomio means atom. So in Greek, atomio means indivisible. So that means the word atom was proposed by, John Dalton. John Dalton. So he proposed a theory known as Dalton's atomic theory. Okay. So according to Dalton's atomic theory, atom is the smallest indivisible particle. The smallest indivisible particle. Okay. Then this theory it is able to explain law of definite proportions and some books it is given as a constant and law of multiple proportions. Law of multiple proportions. And lastly, law of conservation of mass. So this theory, Dalton's atomic theory, was able to explain all these three laws. Okay, and where did he fail? So he failed to explain which is the smallest indivisible particle. According to him, atom is the smallest indivisible particle, but later some experiments revealed that there are some other particles which are much smaller than atom. So those particles are called subatomic particles. What are they? Subatomic particles. What are subatomic particles? Electron, proton, neutron, positron, neutrino, anti-neutrino. Like this, so many are there. Among all these subatomic particles, electron, proton, neutron, they are collectively called fundamental particles. They are collectively called fundamental particles. So let us move to fundamental particles. What are these fundamental particles? What are they? Electron, proton, and neutron. These three are called fundamental particles. So let us see first one. Discovery of electron. Who discovered electron? J.J. Thompson. In which experiment? Cathode ray discharge tube experiment. Cathode ray discharge tube experiment. Then specific charge of electron. Specific charge of electron. This is also determined by J.J. Thompson. Specific charge means charge to mass ratio. What is it? Charge to mass ratio. Then charge on electron. It was determined by Millikan by using oil drop experiment. Oil drop experiment. Next, discovery of proton. So who discovered proton? Goldstein. Who is that? Goldstein. Next, discovery of neutron. Who discovered neutron? James Chadwick. So what was that experiment? When beryllium, nuclides like beryllium, bombarded with helium. Then you'll get carbon and chargeless particle, neutron. Okay, so this is what we call a discovery of neutron. So this is all about fundamental particles, electrons, protons, and neutrons. Then atomic models. So in the first one, Thompson's atomic model. So according to Thompson, atom is spherical in shape. Atom is in spherical shape. Atom is spherical in shape. Okay. Then positive charge. So what we are considering here, this red color indicates positive charge. This indicates positive. What does that mean? So positive charge is uniformly distributed over the entire atom. Positive charge is uniformly distributed over the entire atom. Now in that positive charge, electrons are embedded like seeds in watermelon. That is why this model is also known as watermelon model of atom. Watermelon model of atom. But he could not explain electrical neutrality of atom. Electrical neutrality of atom. There he failed. Then the next model was proposed by Rotherford. Who is that? Rotherford's alpha rays scattering experiment. Rutherford's alpha ray scattering experiment. So what is Rutherford's alpha ray scattering experiment, right? Let us see. This is a lead block. This lead block, let us consider radioactive element.
ಬುದ್ಧ ಅಂಬೇಡ್ಕರ್ನ ಹೊಗಳುವ ಜನಪ್ರತಿನಿಧಿಗಳು ಮೊದಲು ಅವರ ವಿಚಾರ ಮತ್ತು ಕನಸನ್ನ ಸಾಕಾರಗೊಳಿಸಬೇಕು ಎಂದು ಸಲಹೆ ನೀಡಿತು.
So who is that? Could you please your audio in mute? Who is that? Bhavita, or I don't know who is that. So please mute your audio. Bhavita, please keep your audio in mute. Okay, now this is a radioactive element, polonium. He has taken a radioactive element. This is polonium, radioactive element. So what it will do? It will emit some radioactive radiation. Some radiations will be emitted from that radioactive element. Now, what are those radiations emitted by polonium here? Alpha rays. Now these alpha rays are allowed to pass through a thin gold foil. What is this? Thin gold foil of thickness 0.0004 centimeters, and which is surrounded by a zinc sulfide screen. So it is surrounded by a zinc sulfide screen like this. Okay, this is a zinc sulfide screen. Then he observed that most of these alpha rays passed through gold foil without any deflection. So most of these alpha rays passed through gold foil without any deflection. Okay, but some are deflected by small angles, and some are deflected by large angles, and very few alpha particles, they exactly bounced back. So very few alpha particles, they exactly bounced back like this. Okay, so how many? One in around 20,000. Out of 20,000 alpha particles, one alpha particle is bounced back in the same path. Now based on this, he proposed that, most of the atom is empty. Most of the atom is empty, right? And electrons revolves around the nucleus. And positive charge is concentrated in a small portion. At the center of the atom. Called, that center is called nucleus. Okay, now where did he fail? Drawbacks. He failed to explain stability of atom. Right? So this is about Rutherford's alpha ray scattering experiment. Next model, Niels Bohr's atomic model. But before that, we need to discuss some other topics which are related to this Bohr's atomic model. Before that, let us see what is nature of light. So light has both the particle nature and wave nature. Particle nature is explained by Newton in corpuscular theory, whereas wave nature was first explained by Huygens. He proposed that light propagates in the form of wave. Light propagates in the form of wave. This is nature of light, but we'll concentrate more on wave nature of light. Wave nature of light. So let us start regarding light. So the first theory given to explain how light is absorbed and light is emitted. Light is nothing but a form of energy. Light is nothing but a form of energy. So regarding that energy, radiation, let us see first theory, Planck's quantum theory. Planck's quantum theory. According to Planck's quantum theory, energy is directly proportional to frequency. Or remove proportionality and introduce a constant, that is E is equal to h nu. That is E is equal to h nu. So this is expression for energy. Here you can see that what is h? H is Planck's constant. What is h, sir? Planck's constant, and h value is 6.6256 into 10 power minus 34 joule second, or 6.6256 into 10 power minus 27 erg second. Okay, then here you can see energy and frequency are they directly proportional, right? So that means E1 by E2 is equal to nu1 by nu2. But we know that nu is equal to c by lambda. C means velocity of light, light is lambda is wavelength. So you substitute here. That means frequency and lambda, they are inversely proportional. So finally what it will become? E1 by E2 is equal to nu1 by nu2. But nu is inversely proportional to lambda. So it becomes lambda 2 by lambda 1. Okay, so this is about Planck's quantum theory. And next part, photoelectric effect. Photoelectric effect. What is photoelectric effect? When a beam of light, incident on metal surface. Let us suppose this is a metal surface. Then imagine a beam of light is incident on this metal surface. Then what happens? Ejection of electrons takes place. Who is coming out from that metal surface? Electrons. So what is this? Light. Light of suitable frequency. A light of suitable frequency. So this is a photoelectric effect. What is photoelectric effect, sir? When a beam of light with suitable frequency, incident on a metal surface, then ejection of electrons takes place. Ejection of electrons takes place. Okay, so this was explained by Einstein. So let us see Einstein's explanation. So the amount of energy absorbed E is equal to h nu. So this absorbed energy is utilized in two ways. One is the work function, and remaining energy is converted into kinetic energy. So this is h nu naught, is also known as work function. Okay, now make kinetic energy of the ejected electron a subject, then what you will get? H nu minus h nu naught. H, if you can make it common, nu minus nu naught. What is the nu? C by lambda minus C by lambda naught. So finally what you are getting here? H kinetic energy is equal to H. C, make it common, 1 by lambda minus 1 by lambda naught. So this is kinetic energy of the ejected electron, and it was explained by Einstein. It was explained by Einstein. Now, after this, we'll move to hydrogen spectrum. So let us move to hydrogen spectrum. So what is hydrogen spectrum? What is hydrogen spectrum? It's a spectrum which is obtained when hydrogen gas is subjected to electric discharge. When hydrogen gas is subjected to electric discharge, then you will get a bluish light. Hydrogen gas emits a bluish light. When this bluish light is passed through an equal prism, then that bluish light splits into different spectral lines. That means a series of spectral lines are obtained. In that, what is first one? Lyman series. It is obtained in UV region. And in Lyman series, N1 is equal to 1, N2 is equal to 2, 3, 4, and so on. So this is Lyman series. Next. Balmer series. Balmer series is obtained in visible region, whereas N1 is equal to 2, N2 is equal to 3, 4, 5, and so on. Next, Paschen series. So this is obtained in near IR region, where N1 is equal to 3, N2 is equal to 4, 5, 6, and so on. Next, bracket series. So bracket series, this is obtained in middle IR region, where N1 is equal to 4, N2 is equal to 5, 6, and 7. Next, Fund series. So this is obtained in far IR region. N1 is equal to 5, N2 is equal to 6, 7, and so on. Okay, last one. Humphrey series. Humphrey series. This is also obtained in IR region. N1 is equal to 6, N2 is equal to 7, 8, 9. So this is about hydrogen spectrum. Balmer calculated wave number of spectral lines, that is 1 by lambda equal to R into 1 by N1 square minus 1 by N2 square into Z square for hydrogen-like species. For hydrogen-like species. And what is Rydberg's constant for hydrogen? 109,677 centimeter. So this is Rydberg's constant value, right? So this is all about hydrogen spectrum. Let us move to next topic. That is Eisenberg's uncertainty principle. So according to Heisenberg's uncertainty principle, delta x into delta p greater than or equal to h by 4 pi or delta x into m delta v, because momentum is what is p there? P is momentum. Moment formula, mass into velocity is greater than or equal to h by 4 pi. Then delta x into delta v greater than or equal to h by 4 pi m. So delta h and delta v, how they are proportional, sir? Inversely proportional with mass. So therefore, delta x into delta v of a component A by delta x into delta v of, delta v of component B is equal to mass of B by mass of A. Mass of B by mass of Yeah. So this is all about Heisenberg's uncertainty principle. Next. Okay. Next, we'll move to Schrodinger's wave equation. So what is Schrodinger's wave equation? Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V psi is equal to 0. What is psi? Wave function. What is psi? Wave function is total energy and V is potential energy. V is potential energy. So this is Schrodinger's wave equation. If you solve Schrodinger's wave equation, you will get quantum numbers. Solve Schrodinger's wave equation. What you will get quantum numbers. The first one, principal quantum number. This is represented by n. Then number of electrons in an orbit is given by 2n squared. Similarly, number of orbitals in an orbit is equal to n squared. Number of electrons is 2n squared. Number of orbitals is equal to n squared. So this is about quantum numbers. In the first one, principal quantum number. Second one, azimuthal quantum number, which is represented by L. Who proposed this? Sommerfeld. Who proposed this? Sommerfeld. And the significance is it indicates the shapes of orbitals. The shapes of orbitals, right? Next, L values for different orbitals. S, T, D, F orbital. L value for S orbital is 0. T value L orbital is, for L orbital is 1. For D it is 2. F it is 3. Okay. Now in addition to this, if you say that for different L values, there are different orbitals. There are different orbitals. Next quantum number, magnetic quantum number. So what is magnetic quantum number? It was proposed by Landé. Who proposed this? Landé. And by using a magnetic quantum number, we can, it describes orientation of orbitals. It describes orientation of orbitals. Then M values are from minus L to plus L, including 0. So what are M values, sir? Minus L to plus L, including 0. Right. So this is about magnetic quantum number. Last one is spin quantum number. What is the last one? Spin quantum. So let us see what is spin quantum number. So please mute your audio. Is that Coco? Coco M3, who is that? Please. Please always keep your audio in mute so that we can continue our class, right? So don't disturb the class. The last one, spin quantum number. So spin quantum number, it was proposed by Uhlenbeck and Goldsmith. Okay, now the spin quantum number describes the direction of spin of electrons, the direction of spin of electrons. So S has only two values, plus half and minus half. Plus half is for clockwise electronic spin, minus half is for anti-clockwise spin of electron, anti-clockwise spin of electron. So this is all about quantum numbers, right? So last part in this chapter, Aufbau principle. Just we am giving just outline of atomic structure. Then we'll move to some previously asked CET and NEET questions. Then we will solve those numericals, right? So Aufbau principle. What is Aufbau principle? Electrons are filled into orbitals in increasing order of energies. Increasing order of energies, right? So how to determine increasing order of energies? So for that we have n plus L value rule. So what is this n plus L value rule, sir? So according to n plus L value, orbital with lowest n plus L value will be filled first. So which orbital is filled first? Let us suppose, if you consider example 4s and 4p. What is n plus L value? N is 4 here. L value for s orbital 0, that is 5. Sorry, 4. Here n plus L value for 4p orbital. N value is 4. L value for p orbital is 1. So now it is 5. Who is having lowest n plus L value? 4s. So 4s orbital is filled first. 4s orbital is filled first. If now there is some special case included here, so that means, what is that special case? If two orbitals have same n plus L value, let us suppose 3D and 4p. What is n plus L value? 3 plus 2, which is equal to 5. 4 plus L value for p orbital 1, that is also 5. So now 3D and 4p have same n plus L value. Then which orbital will be filled first? Then orbital with the lowest n value will be filled first. So which orbital is having lowest n value? 3D. So 3 is lowest, right? So 3D orbital will be filled first, then 4p, then 4p. That is Aufbau principle. Next, Paulie's exclusion principle. So what is Paulie's exclusion principle? No two electrons can have the same set of all four quantum numbers. Okay, let us suppose 4s2. How many electrons are there? 2 electrons. Let us suppose first electron. The first electron is present in which orbit? Fourth orbit. Which orbital? S orbital. S orbital L value 0. If L is 0, M value will be minus M2 plus L including 0. So minus 0, 2 plus 0 including 0. That is M value 0. Half. Let us suppose clockwise spin. So it will be plus half. Next, for second electron, because one more electron is there in 4s orbital. That electron is also present in fourth orbit, s orbital, and for s orbital L value is 0, and remaining orbital, remaining electron will be having anti-clockwise electronic spin. That means minus half. So here, no two electrons can have the same set of all four quantum numbers. What does that mean? At least they should differ in spin quantum number. In the given example, you can see clearly there is a difference in spin quantum number. Understood, right? So this is about Paulie's exclusion principle. Last point in this chapter, Hund's rule. According to Hund's rule, pairing up of electrons takes place only when each degenerate orbital is filled with one electron. So pairing up of electrons takes place even first each degenerate orbital should be filled with one electron. What are degenerate orbitals here? Degenerate orbitals means orbitals having same energy. These degenerate orbitals have same energy. So that is why they are called degenerate orbitals. Let us consider one example. Nitrogen. What is its electronic configuration? 1s2, 2s2, 2p3. Right. Now if you consider 2p, so how many electrons are there? 3 electrons. 1, 2, 3. This is wrong. And how we should represent? First each degenerate orbital should be filled with one electron. 2, 3. So this is correct expression. This is 2p3. This is 2p3. So what is Hund's rule? Pairing up of electrons takes place only when each degenerate orbital is filled with one electron each. One electron each. Done. Then this is all about some important points in atomic structure. So let us move to numerical part now, right? So we'll start with some previously asked CET questions. Then we'll move to some important models for CET. Important models for CET, right? So let us start first some previously asked questions. Some previously asked questions, right? We'll discuss one by one. We'll discuss one by one. So this is a CET 2020 question. CET 2020 question from atomic structure. From atomic structure, right? So what is the question? So let us take the question first with regard to photoelectric effect. So this question is based on photoelectric effect. Photoelectric effect. Identify the correct statement. Identify the correct statement. So what are those statements given, sir? First statement, number of electrons ejected. What will happen in photoelectric effect? Electrons will be ejected. So number of electrons ejected increases with increase in work function. Increase in work function. This is first statement. So is there any relationship that as work function increases, number of electrons increases? Next option, number of electrons ejected increases with increase in the intensity of light. With increase in intensity of light. Third option, energy of ejected electrons increases with increasing intensity of light. Intensity of light. Last option, number of electrons ejected. Number of electrons ejected increases with the increase in the frequency. Increase in frequency of radiation. So which option will take as the correct option, right? So photoelectric effect is already we discussed, that is regarding ejection of electrons. That is ejection of electrons. So there are two things you have to understand here. So two things, number of electrons ejected increases with the increase in intensity of radiation. So what is that, sir? Which option? B. Option B is correct, right? So what is that? So number of electrons ejected is directly proportional to intensity of radiation. Intensity of radiation, right? This is one point. So number of electrons ejected is directly proportional to intensity of radiation. Second point, kinetic energy of electrons ejected is directly proportional to frequency of radiation. So these 2 points you should remember, right? So when it comes to photoelectric effect, number of electrons ejected increases with the increase in intensity of radiation, whereas kinetic energy of ejected electrons increases with frequency of the light increases. The frequency of light increases, right? So this is a CET 2020 question. Next we'll move to CET 2019 question. CET 2019 question. So let us see CET 2019. The question is, this is actual numerical. So two particles A and B are in motion. So there are two particles A and B are in motion as they are moving. If the wavelength associated with A is, so wavelength, if the wavelength associated with A is 33.33 nanometers. 33.33 nanometers. and the wavelength associated with B and wavelength associated with B whose momentum is 1/3 of A is 1/3 of A is. So we have to find out wavelength associated with B. Okay, now options given are 2.5 into 10 power minus 8 meters. Second option, 1.0 into 10 power minus 8 meters. Third option, 1.0 into 10 power minus 7 meters. Last, 1.25 into 10 power minus 7 meters. So this is a numerical given here, right? So what we know here,
Wavelength of A.
according to de Broglie, what is wavelength? Lambda is equal to h by p. That means Planck's constant by momentum, h by p. So here you can see lambda and momentum, how they are related, inversely proportional. Then if you take two cases here, A and B, lambda A by lambda B is equal to inversely proportional momentum of B by momentum of A. But what is given? Momentum of B is exactly how many times? 1/3 of A. 1/3 of A. So we just substitute it here. So lambda A by lambda B is equal to, what is PB, sir? 1/3 of A by A, right? Then what you will get, A gets cancelled, that is equal to 1/3. So lambda A is equal to lambda by lambda B is equal to 1/3. So finally, so lambda, what we need? B. Lambda B is equal to 3 times lambda A. 3 times lambda A. So what is lambda A given there? 33.33. So this is 3 into 33.33. So what is it? 100. So it is given in 100 nanometers. Okay, so 1 nanometer is equal to 10 power minus 9 meters. So 100 into 10 power minus 9. 100 into 10 power minus 9. That means 100 we can write as 10 square into 10 power minus 9. What you will get? 10 power minus 7. So this is in meters. This is in meters. So where is the 10 power minus 7 meters, sir? 1 into 10 power minus 7. So this is the correct option, right? So this is a question asked in CET 2019. CET 2019. Then question asked in 2018, right? Shall we proceed? So let us move to question asked in 2018. So CET 2018. So let us see that question first. The orbital nearest to the nucleus is. The orbital nearest to the nucleus is. Options given are 4f orbital, next 5d orbital, third option 4s orbital, fourth option 7p orbital, right? So Which orbital is nearest to the
C, sir. 4s. 4s orbital.
4s orbital. Right? So why it is nearer to the orbit nucleus?
ಸರ್ ಅದು ಎಸ್ ಪಿ ಮತ್ತೆ ಡಿ ಎಫ್ ಬ್ಲಾಕ್ ಅಲ್ಲಿ ಅರೇಂಜ್ ಆಗುತ್ತೆ ಅದರಿಂದ 4s ಬಂದಿರೋದ್ರಿಂದ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ.
Okay. So if you consider this is a nucleus, first orbit, second orbit, third orbit, fourth orbit, fifth orbit, sixth orbit, seventh orbit. So 1, 2, 3, 4, 5, 6, 7. Let us suppose now we are having which orbits in the given question. So we are having almost 4f. Here one orbital is there, right? Then 5d. Here one more orbital. Next 4s. Here also we have s orbital. Then 6 is nothing is given, 7p. Now among all these orbit, which orbit is close to the nucleus? Fourth orbit. Now in fourth orbit, we have 4f and 4s orbitals. Both we have, but we know that s orbital is very close to the nucleus. S orbital is very close to the nucleus. Then p orbital, then d orbital, then f orbital, right? So correct option is, as you said, 4s orbital. Then we'll move to CET 2017. CET 2017 question. This is based on quantum numbers, right? So let us see the question. The correct set of quantum number. The correct set of quantum number for the unpaired electrons. For unpaired electrons of chlorine atom is, which atoms are? Chlorine atom is. So this is what we have to find out in chlorine atom. The options given are 2, 0, 0, plus half. Second option 2, 1, minus 1, plus half. Third option 3, 1, 1, plus or minus half. And last option is 3, 0, 0, plus or minus half. Plus or minus half. So this is given question. So let us find out what is correct set of quantum number for the unpaired electrons in chlorine atom. So first write down what is chlorine atom's electronic configuration. What is atomic number? 17. So it will be 1s2, 2s2, 2p6, 3s2, 3p5. So 3p5 orbital is having total 5 electrons here. So how many electrons are there in p orbital? 5 electrons. So let us write down 1, 2, 3, 4, 5. So this is the unpaired electron. This is the unpaired electron. Now this is present in which orbit, sir? Third orbit. So let us write down N, L, M, S. Now in the third orbit, electron is present. So third, and which orbital? P orbital. P orbital L value 1. If L is equal to 1, M may be plus 1 or minus 1. Let us suppose it is 1. And spin quantum number for this unpaired electron, this may be plus or minus half. Plus or minus half. Now, in which case you will have all these values. Which option, sir? Third option. So it gives 4 different quantum number values for the last unpaired electron present in p orbital, that is px, py, pz orbital. So the electron is present in pz orbital. The electron is present in pz orbital. So this is about previously asked CET questions. Previously asked CET questions. Okay. So now let us see some of previously asked NEET questions also. So 2 to 3 questions we'll check. Then let us see if we find time, then we'll move to some other questions also, right? So let us see 2021 NEET. NEET 2021. The question is, from the following pairs of ions, from the following pairs of ions, which one is not an, which one is not an isoelectronic pair? Isoelectronic pair. So we need to identify which is not isoelectronic. Options given are Fe plus 2, Mn plus 2. Second option, O minus 2, F minus. Third option, Na plus, Mg2 plus. Fourth option, Mn2 plus and Fe plus 3. So these are the options given. Now you need to find out which is not isoelectronic. Which is not isoelectronic means
O to O minus to F minus.
really. What is isoelectronic means?
So same electronic idirbeku. Numbers irbeku ಮೇಲ್ಗಡೆ ಇರುತ್ತಲ್ಲ atomic number ಆ ತರ same
The
ಇರ್ಬೇಕು.
number of electrons. Not isoelectronic means should not be the same. Number of electrons should not be the same, right? So as you are saying, let us consider your option only. Oxygen, O minus 2. O minus 2 means oxygen is actually having 8 electrons. The negative charge indicates addition of 2 electrons. So how many electrons are they? Total 10 electrons. Next, F minus. F minus, fluorine is actually 9. Negative sign indicates addition of electron. Minus 1 means plus 1 electron. So total 10 electrons. So if they are having same number of electrons, they are called isoelectronic species. So they are isoelectronic. But the question, what we need, sir, which are not isoelectronic, which are not isoelectronic. So second option is ruled out. That is not answer. Second, next we'll move to one more option. That is Fe plus 2. Iron is having 26 plus 2 means loss of 2 electrons. So how many electrons will be there? 24 electrons. Next, manganese plus 2. Manganese is atomic number 25. That means 25 electrons in neutral, but loss of 2 electrons. Loss of 2 electrons here also. That means minus 2. So here you are having 25 minus 2. What is that? 23 electrons. How many electrons are there? 23. So Fe plus 2 is having 24 electrons. Mn plus 2 is having 23 electrons. So both are not having same electrons. So they are not isoelectronic because they don't have same number of electrons. If they have same number of electrons, they are termed as isoelectronic. So this is a question asked in 2021 NEET. Then we'll move to question asked in 2020. 2020. Okay. Did you understand now?
Yes, sir.
Okay, next question. NEET 2020. The question is, this is also a simple question. The number of protons, this is basic level question only. Number of protons, neutrons, and electrons in lutetium 71, 175 respectively are. So we need to find out what we need to find out: number of protons, neutrons, and electrons. Options given are 71, 104, 71. Next, 104, 71, 71. Next, 71, 71, 104. Last one, 175, 104, 71. Right? These are the options. So first, what are the
Yes,
given
sir.
order? Which one?
Yes, sir.
A. So let us check. You are saying A. Let us cross check it. First one, number of protons. What is given, sir? Lutetium 71, 175. So this represents atomic number Z. This represents mass number A. Number of protons is equal to atomic number, that is 71. Next, number of, we need neutrons. Number of neutrons formula, A minus Z. What does that mean? 175 minus 71. What you will get, sir? 104, right? This is number of neutrons. Lastly, number of electrons. Number of electrons is equal to atomic number in a neutral atom. So that is again 71. So what is that order? Number of protons 71, number of neutrons 104, number of electrons 71. So which option? Correct option is A. What is correct option? A. Done. Next question. So I'm moving to next question. One more question we'll solve. Be plus 2 beryllium is isoelectronic with which of the following ions? Which of the following ions? Options given are H plus, Li plus, Na plus, and Mg plus 2. So first find out what is isoelectronic having same number of electrons. In Be plus 2, what are number of electrons? So actual beryllium is 4, plus 2 means loss of 2 electrons. So that means Be plus 2, how many electrons are there? 2. Now among the following options, which is having 2 electrons? If you consider lithium, Li plus, lithium is 3, plus represents loss of 1 electron. So in Li plus also we are having same number of electrons. So Be plus 2 is isoelectronic with lithium ion. Be plus 2 is isoelectronic with lithium ion. Okay. So we'll move to next question. A 0.66 kg ball is moving with the speed of 100 meters per second. Then the associated wavelength will be, options given. Here H value is given, Planck's constant, that is 6.6 into 10 power minus 34 joule second. So this value is given. Options given are 6.6 into 10 power minus 32 meters, 6.6 into 10 power minus 34 meters, C 1.0 into 10 power minus 35 meters, last option 1.0 into 10 power minus 32 meters. So what is that correct option for this question? So what is
Option A,
6.6 into 10 power
32. Minus 32.
Okay, let us find out. So actually this question is based on which topic? What is given? Mass is given, that means the m is given. Next, velocity, speed is given. Then h is given. What we need to find out? Lambda. So according to de Broglie, lambda is equal to h by mv. H by mv. Then what we need to find out? The question is about the associated wavelength will be. Lambda only we need to find out. So what is formula, sir? Lambda is equal to h by mv. What is h value given there? 6.6 into 10 power minus 34. 6.6 into 10 power minus 34 by, what is mass given? Mass is 0.66 kg. 0.66 kg. Then what is speed? Velocity. Velocity is given 100 meters per second. So multiplied by 100. Then what you will get? 6.6 into 10 power minus 34 by 0.66 into 100. What you will get, sir? 0.66 into 100. Then you will get 66. Right. Then 6.6 divided by 66. How many times? 10 times. So 10 power minus 34 by 10. It means 10 power minus 34. 10 becomes 10 power minus 1. That is 10 power minus 35 meters. So 1 into 10 power minus 35 meters. Which option? Let us see. There is 1 into 10 power minus 35 meters. Third option. So it is not 6.6 into 10 power minus 32. It is actually 1.0 into 10 power minus 35 meters. Did you understand?
Yes, sir.
Okay. We'll solve one more question. The uncertainty in momentum. The uncertainty in momentum of an electron is 1 into 10 power minus 5 kg meters per second. Okay, now the question is the uncertainty in its position will be. in its position will be, and here also H value is given. H is equal to 6.62 into 10 power minus 34 kg meter square per second. So this is Planck's constant. This is Planck's constant. Options given are 5.27 into 10 power minus 30 meters. Next, 1.05 into 10 power minus 26 meters. Third option, 1.05 into 10 power minus say 28 meters. Last option, 5.25 into 10 power minus 28 meters, right? So we need to find out uncertainty in position. Uncertainty in position. What is the expression for this? According to Heisenberg's uncertainty principle, delta x into delta p is greater than or equal to h by 4 pi. H by 4 pi. So what is given? Uncertainty in momentum. Delta p is given. We need to find out delta x. So delta x is equal to h by 4 pi into delta p. So what is h value is given? Already it is given 6.62 into 10 power minus 34 by 4 into pi value 3.14 into what is delta p is given, uncertainty in momentum. What is uncertainty in momentum? 10 power minus 5. 10 power minus 5. Okay. So what you will get? So 6.62 by 3.14. So calculate. So just you bring it here. 10 power minus 34, 10 power minus 5. What it will become? 10 power minus 29. 6.62 by 4 into 3.14. Okay, so here you can do that in a rough manner, right? 4 into 3, denominator part, 4 into 3, 12, here 6.62. So around, let us suppose 2 times. 1 by 2 is 0.5 into 10 power minus 29. Then what it will be? 5 into 10 power minus 30. So where we are having 5 into 10 power minus 30 meters. So first option itself. What is that? First option, 5.27 into 10 power minus 30, 10 power minus 30. Done? We'll move to next question then. So let us solve one more question, same model. Uncertainty in position. Uncertainty in position of an electron. Now its mass is given. Mass of electron is 9.1 into 10 power minus 28 grams. Moving with a velocity of, that means that electron is moving with a velocity of 3 into 10 power 4 centimeters per second. Accurate up to 0.001% will be. Okay. Here H value is given, that is 6.626 into 10 power minus 27 erg second. Okay, so all values are given in CGS system, right? Options 5.76 centimeters, next 7.68 centimeters, third one 1.93 centimeters, last one 3.84 centimeters. So all are given in centimeters. That means they are considering every value in CGS system, right? So now what is velocity of electron given? 3 into 10 power 4 centimeters second. But what is its accuracy? 0.001%. That means uncertainty in velocity, that is delta V, is equal to 3 into 10 power 4 into 0.001%. That means 0.001 by 100. What is that? So it is equal to 3 into 10 power 4, 0.001. That is 10 power minus 3 by 10 power 2 here. So what it will become? 3 into 10 power 4 into 10 power minus 5. So that is 3 into 10 power minus 1. That is 0.3 centimeters per second. So this is uncertainty in its velocity. Uncertainty in its velocity. Now what is our formula? Same. Delta x into delta v is equal to h by 4 pi m. What we need here? Uncertainty in position. What we need to find out? Delta x is equal to h by 4 pi m into delta v. What is h value given? 6.626 into 10 power minus 27 divided by 4 into 3.14. Mass is 9.1 into 10 power minus 28 grams. Then delta v, just now we calculated. What is delta v? 0.3. So it's just calculate that fraction, find out what is that value you are getting there. So you should go to 1.93 centimeters. After calculating the fraction, you should get 1.93 centimeters. So that should be your answer, right? So which is that correct option here? Third option, 1.93 centimeters. Okay, so this is one more different question. Then shall I move to one more question? Simple question. The total number of atomic orbitals, the total number of atomic orbitals in fourth energy level, of an atom is, of an atom is? Options given are 8, next 16, next 32, next 4. Okay, so total number of atomic orbitals in fourth energy. Fourth energy means fourth energy level, n is equal to 4. Then what is formula of number of atomic orbitals in a given orbit is n square. Here n is 4, that is 4 into 4, so 16. So how many number of atomic orbitals are there in fourth energy level? 16, right? Next, move to next question. How many electrons can fit? How many electrons can fit in the orbital? In the orbital for which n is equal to 3 and L is equal to 1. So options are 2, second option 6, third option 10, last fourth option is 14. So how many electrons can fit in the orbital? What is the n, sir? It is given that n is equal to 3, L is equal to 1. L represents the number of orbital. In which orbit? Third orbit. L is equal to 1 means p orbital. N is equal to 1 means L value is 1 for p orbital. So we know that in 3p orbital, how many electrons can be fit into p orbital? 6 electrons. How many electrons are can be fit in that p orbital? Total 6 electrons we can fit into the p orbital, right? So this is about number of electrons in a given orbital. Number of electrons in a given orbital, right? Next, one more question we'll see, then we'll wind up this session. The Bohr orbit radius, the Bohr orbit radius for hydrogen atom, for hydrogen atom, that is n is equal to 1, is 0.530 Armstrong units. Then the radius for excited state, for the excited first excited state, that is n is equal to 2. Orbit is, this is in Armstrong units, you need to find options 4.77, 1.06, 0.13, and lastly 2.12. Okay, so here we need to find out the radius for the first excited state. What is the formula for radius of nth orbit? That is radius in first orbit into n square. N square means number of orbit. Radius in the first orbit is given. What is that? 0.53. It is given into which orbit, sir? N is equal to 2. Here we need to find out. N is equal to 2 means 2 square. 2 square means 0.53 into 2 square is 4. 2 square is 4. Then what you will get? 4 into 0.53, that is 2.12 Armstrong units. 2.12 Armstrong units. So that is the last option. 2.12 Armstrong units. Right. So these are some important models in this atomic chapter. Right. So that's it for this session. We'll meet you in the next session tomorrow, and we'll continue with some new chapter. Right. So that's it for this session. Meet you tomorrow once again. So good night, all of you.
Thank you, sir.